So let's draw some structures for these. First of all, meth. Meth stands for one carbon. Methane, double that, you get 2. Add 2, you get 4, CH4. Ethane, eth means 2 carbons. To find the hydrogens, double 2 is 4, add 2 is 6. The carbon goes here, and the hydrogens go around it. And that's a molecule of methane. Ethane has 2 carbons in a row, and then this carbon has 1 bond, it needs 3 more. This carbon has 1 bond, it needs 3 more, and you put hydrogens at the ends of each of those bonds. Prop means 3 carbons. Double 3, you get 6. Add 2, you get 8. C3H8. 3 carbons in a row. This carbon has 1 bond, it needs 3 more. This carbon has 2 bonds, it needs 2 more. This carbon has 1 bond, it needs 3 more. And then you just slap the hydrogens on the other end because it is a hydrocarbon. And that's a molecule of propane. That's what you burn when you cook things on your gas grill. Butane. But means 4 carbons. For the hydrogens, we'll double the 4, that's 8. Add 2, that's 10. 4 carbons in a row. And this carbon has 1 bond, needs 3 more. This carbon has 2 bonds, needs 2 more. This carbon has 2 bonds, needs 2 more. This carbon has 1 bond, needs 3 more. And on the other end of those bonds, we've got hydrogen. Butane. Butane is very flammable. We love our cars, don't we? Yeah, we like them to get good gas mileage. When you pull up to the gas station, you've got a choice of different octanes you can get. Now what's octane? Octane is a molecule that contains 8 carbons, and because it's an alkane, double 8, you get 16. Plus 2 is 18. CH18. 8 carbons in a row. The carbons on the end each need 3 more bonds, and the carbons in the middle only need 2 more to have a total of 4 bonds. What goes on the other ends of those bonds? Yeah, hydrogen. Now here's a neat little trick. As long as you understand that hydrogen is on the other end of those bonds, you don't actually need to write the H's. As long as you know that they're there. In a hydrocarbon, the H is implied. But we're going to draw them anyway. 18 hydrogens. Now this actually isn't the same molecule that goes into your gas tank. What you get in your gas tank is what's called isooctane. There's many different ways of arranging these 8 carbons and 18 hydrogens to make it more fuel efficient and to cut down on engine knock. We'll talk about that when we talk about isomers in the next topic. Alkenes. Ethene, 2 carbons with a double bond. Propene, 3 carbons with a double bond. Does it matter where the double bond goes? Does it matter where the double bond goes? In this molecule, no. Ethene is C2H. Well, in alkenes, you double the carbons. 1, 2, 3, 4. Alkenes, 2 bonds, 2 more needed. 1, 2, 3 bonds, 1 more needed. 1 bond, 3 more needed. Or, and for the sake of time, I'm not going to draw the hydrogen. Remember, they're implied in a hydrocarbon. Now, why doesn't it matter which one of these 2 you use? Why are they the same? These molecules are 3-dimensional. If you pick this up and turn it around, you'll get that. Butene, 4 carbons. 1, 2, 3, and 4. And somewhere on the chain, there's a double bond. Well, there's a couple different places we can put it. We could put it between these 2 carbons. We could put it between these 2 carbons. Or we could put it between these 2 carbons. We're faced with choices. Let's put it here. And then we'll fill in the rest of them with hydrogens. So that's, let's see, H, and that's 1, 2, 3, 4, 5, 6, 7, 8. Which makes sense because you have to double the carbons to get the hydrogens in an alkene. But this is also butene. 1, 2, 3, 4. Boom! In the middle. These are both butene, but they're not the same molecule. If you look at this, this has less symmetry than this does. Look how nice and symmetrical that is. Double bond is in the middle. So what you do is you put a number in front of the name of the molecule to indicate what the lowest numbered carbon that double bond is on. So this is called 1-butene, because the double bond is touching the first carbon in from the end. And we call this 2-butene, because the double bond is touching the second carbon in from the end. If you go in from this end, it's still the second carbon. Now you might look at this and say, well, why isn't it 3-butene? Well, I just got finished saying, you use the lowest possible numbered carbon when you number it. We could have drawn the molecule like this too. Would this be 3-butene? Nope. It's one carbon in from the end. So you count how many carbons are in from the end on the shortest side. And that's how you can name this particular isomer. Oh, what a word. Isomer. Do you remember back when we did nuclear chemistry, we did something called isotopes, like 14,6C and 12,6C. These were isotopes, where they were the same element but different mass. Well, isomers are the same molecular formula. They're both C4H8, but their structural formulas are different. The molecules are arranged differently in space. So isomers are molecules that have the same molecular formula, but they have different structural formulas. They're arranged differently in space. So if you want to name an isomer of an alkene, take a look at where the double bond is located, number the carbons starting from the side the double bond is closer to, and then the lowest numbered carbon that the double bond is on has its number placed in front of the isomer's name. 1-pentene, pent is 5 carbons. 1-pentene tells me that the double bond is bonded to the first carbon in from the end. Which end? It doesn't matter. Eeny, meeny, miny, mo, catch a tiger by the toe. If he hollers, make him pay $50 every day. Okay, I'll put it there. Doesn't really matter. I could have put it here too. It would have still been 1-pentene. C5H10. So what about 2-pentene? Well, it's still going to be C5H10 because pent is pent. But now, the double bond is on the second carbon in from the end. That means it could either be here or it could be here. 1, 2, there's a double bond, or 1, 2, there's the double bond. I'll throw it there, why not? And there we have 2-pentene. Isomers of each other. Same molecular formula, but their structural formulas are different. Now, is there such a thing as 3-pentene? Let's see. Here's pentene. We count 3 carbons in from the end. 1, 2, 3, we put the double bond there. Wait, that's not 3-pentene. It's 2-pentene. Therefore, there's no such thing as 3-pentene. Just for fun, let's do some alkynes. Ethane, C2H, let's draw it. 2 carbons, alkynes have a triple bond in between them. That means this carbon's got 3, only has room for 1 more. This carbon's got 3, only has room for 1 more. H2. Double and subtract 2. Propyne, C3H. Well, we got 3 carbons. And again, does it matter when we put the triple bond? No. There. This carbon's got 3, room for only 1 more. This carbon's got 3, 4. It's got 4. There's no more room for hydrogens. This carbon's got 1, room for 3 more. 1, 2, 3, 4 hydrogens. Double 3, you get 6. Subtract 2 and you get 4. What do we name this molecule? Here's how to name it. 1, 2, 3, 4, 5, 6 carbons. 6 carbons is hex. Triple bond, ine, for an alkyne. Now, how many carbons in from the end is that triple bond? Well, counting from this side, it would be 4 carbons in. Counting from this side, it's 2 carbons in. We always go with the lower number. Always, always, always. And that's how you write formulas for and name hydrocarbons.